begin. I have muted all the participants on the call, as it certainly makes it easier to hear the virtual presentation without any background noise. I would also like to ask that everyone turn off their cameras to help with bandwidth during the webinar. I'd like to highlight where a few important Zoom functions are, should you need to use them while on this webinar. And this may be a little bit different whether you're running a iPad or a desktop computer, but I'm sure you'll be able to figure it out. At the bottom left, you see the microphone icon. This is where you can mute and unmute yourself. To the right of the microphone icon is the camera icon, and that you can use to turn your camera on or off. 4 icons to the right of the camera icon is the chat function for the webinar. There will be a facilitated question and answer during the presentation where participants will be able to write their questions in the chat function. We will have one of the directors that will monitor the chat. So if you have a question during the presentation, please write it in the chat function and we will certainly be able to get it to Dr. Morgan as we go. There will also be time for a Q&A after the presentation. Lastly, this presentation will be recorded and will be shared by both the Alberta Sheep Breeders Association and the Alberta Lamb Producers. And the ASBA would really like to thank and acknowledge the contribution of the Alberta Lamb Producers in sponsoring this webinar for us. Thank you very much, Ashley. Okay, I would like to introduce our presenter this evening. And this is Dr. Jim Morgan. Dr. Morgan will be giving his presentation utilizing performance data for selection tonight from Fayetteville, Arkansas. Jim received his degree in biology from Southwestern College in Kansas, his master's degree in biology from the University of Oregon, and his PhD in zoology from Oregon State University. He grew up on a mixed farm in Kansas and has been involved in the sheep industry for many, many years as a researcher, presenter, author, teacher, and breeder. He was a key driver and a participant in the development of genetic tools for Katahdins. And as a result, the Katahdin breed was the first breed of sheep in the US to be able to effectively select for a cross-flock parasite resistance and a cross-flock maternal performance for commercial sheep producers. Jim has provided outreach and presentations to farmers and educators across the United States, as well as in Canada, Mexico, and Brazil. His dedication to the sheep industry is evident in the committees he has served on, he has given, commissions he has written in both the popular press and scientific journals. His complete bio is considerably longer than this, and we will definitely make it available for you on our website for anybody who would like the rest of the information. So with that, I will turn it over to Dr. Jim Morgan for his presentation.
Thank you for inviting me to give a presentation. I was at a sheep meeting in Alberta in 1999. There was a Katahdin meeting hosted there, and we attended and had a great time. The point of this talk is to work on getting more flocks involved in performance evaluation, and so that's a driver, and been one of the main reasons I've stayed active and as a teacher is to try to help sheep breeders understand why it's important to do it. Okay, so I'm going to give a couple examples of a few industries that have implemented performance data evaluation and the impact on the breeds, or on the species. I guess actually species, not the breeds. Okay, this is a graph of the US beef cattle industry from 1969 to 2009. And the reddish line is the meat production, and the other line is the cow inventory. So you can see the first third of this slide, the meat production and cow numbers increased together. In other words, the same amount of meat was being produced per cow per year each of those years. Then starting in the late 70s, early 80s, they started to diverge. And as you can see, the cow numbers went down, but meat production kept going up. And about the point they started diverging is when the beef industry started using expected progeny differences. And that's basically what the text on the next slide. So they're producing much more meat with fewer cattle. And this is the Australian sheep industry, and this starts in 1990. And they also they started using performance evaluation in about 1990. And that's about the time that their ewe inventory started dropping. But lamb production, numbers of lambs per ewe has gone up. So they've used performance evaluation to improve number of lambs per litter. I mean, there's other factors involved. There's improved feeding technologies. I mean, Australia started moving away from the Ramblay, so that a part of the change would have been a breed change, but they're able to move more effectively using, performance evaluation. And it's called best linear unbiased prediction. They started it in the 1950s. First for dairy, at Iowa State University, and then it wasn't until the computer power really started increasing in the 80s and 90s that EPDs have been, or estimated breeding values have been available. So everybody hearing me fine? Am I coming across okay?
You are for me, yep.
Okay, good. So we're going to look at a few of the standard practices of identifying superior genetics, or how we select breeding stock. And we'll start out with a question. We'll start out with a question. So how many of us would spend $500 or $1,000 or $2,500 on who will be the champions of the National Hockey League after the first game of the season? Well, not likely, unless we have money to throw away. But many of us do just that by picking a ram with little performance data. A ram at 3 to 7 months of age. And for most traits, that's only 10 to 30% accurate at the differences between him and between other cohorts in there. So we're doing it with, we wouldn't do that with a hockey game, but we do it with our farm and enterprise all the time. So we need better techniques for evaluating or accurately identifying performance. And so to me, the question is, why is it so difficult? I can look at this ram, or I can weigh this ram at 50 days or 100 days, and this one's 5 kilograms heavier, this one's 20 kilograms heavier. I use that ram, and well, I don't notice any difference this year or next year than I did the previous year. So what's the difficulty? The difficulty is that it's not that easy to without help, accuracy in identifying the superior animals for whatever trait you're looking at, whether you're looking at trying to improve number born or number weaned or growth or muscling. Wool's a little easier, but still, it's accuracy. And we all know that between, that this flock, if your neighbor's flock or somebody you might buy a ram from feeds a lot more corn or alfalfa than you do, his sheep are probably going to be bigger just based on, just on the inputs. But even within your own flock, animals that are born within a week or two of each other, it's still hard at 50 days to get any reasonable accuracy.
Recording in progress.
So one of the classic ways that many people use is that they use visual. We go to the show ring and pick out animals. So, and is this a very accurate way of identifying better genetics? And so here's a group, here's a group of ewes. So we look at these ewes. So, I mean, which one's going to have the growthiest lambs? Which of these ewes are more likely to have twins or weaned twins? And I bring up the twinning and weaning. It has the biggest impact on productivity in our commercial flocks. It's the flocks that have twins and weaned twins that are going to be most productive. You can use a sire to improve growth, but it's the twinning that's important. And you just can't look at a ewe or a ram and tell whether they're going to be reproductively successful. Now there are, again, I will mention that you do need to use visual for structural correctness, and if you're selling breeding stock, it probably pays to have them visually appealing and not too ugly. Commercial flocks, that's much less important. It's the pounds of meat and number of lambs being marketed. And and a dogma of the show ring is that muscling can be assessed visually. And so how many of you think that muscling can be visually assessed accurately? Well, let's look at the results of briefly look at the results of two major studies. There was one done about 30 years ago with Ohio State, University of Illinois, and North Dakota State. They looked at 15,000 lambs. They took 65 live animal measures. And so they were using a tape measure. It wasn't a subjective, this person saying, well, this one's got a longer loin, this one's got a bigger shank. They actually took a tape measure to the animals. And the same thing was done about in the early 2000s at the U.S. Sheep Experiment Station in Idaho. And in Idaho, they took
Oh, for fuck's sake.
length of loin, length of neck, you name it, they measured it, and then they adjusted those for the weight of the animal. Well, here's just a few carcasses hanging. So they looked at, you know, and we're just going to look at some of these, but they adjusted for animal weight. And remember, I said they used a tape measure. So which of these predicted carcass merit? Did length of the animal or length of the loin? Most people would say that's what probably the most important for value of an animal looking at it. Diameter of the shank, width at the shoulders, leg scores. And of course they had the weights because they were adjusting for weights. And on the meat yield carcass value, there's no impact when they measure the length of the animal or length of the loin in the live animal, no impact. Diameter of the shank, no impact. Width at the shoulders, no impact. Leg scores, the earlier study found that leg scores help predict meat yield, and the later one did not. And of course, heavier animals have more meat. So so our technique of visually evaluating which animals have the most muscle visually is not effective. So the show ring has its place, it has its value, but it's not, you know, with the current technologies that we have, it's not a valuable way to predict muscling or predict animal value. You know, but the show ring's an industry, and it's a decent industry, but if we're looking at commercial meat production, which is what this presentation is about, it's not important. You know, if you have access to ultrasound of the loin eye and fat depth is predictive of meat yield, and it can be used in genetic selection programs. And the other problem, you know, if I check the loin eye depth of lambs on my farm and on another farm, you know, you have to adjust for age, you have to adjust for weight, but if they're fed and managed, you know, I can take the same genetics and make them 30 to 40 pounds heavier, or, you know, 20 to 25 kilograms heavier at 120 days, just by differences in feed. So of course those are going to have a bigger loin eye. So, you know, even with techniques that, you know, like weight, both weight and ultrasound can detect differences in value, but unless you control for management, they're not an accurate way of identifying superior genetics. You know, we need another tool to go along with those. Another thing that's, you know, that's tempting to do is to pick the biggest ewe or ram lamb in the selection pen. You could weigh them and get a little better data, but if you're picking just the biggest, whether on weight or size, you know, there are several you know, a lot of people do it, but there's several non-genetic factors that impact size and weight. The age of the dam, you know, a 4-year-old ewe is going to have bigger lambs than a yearling, you know, and whether they have triplets, twins, or singles is all going to affect their growth and the size they are in the selection pen.
Just excuse me for a minute. Can I just get everybody to mute themselves and turn their cameras off again, please? Thank you. Excuse me, Jim.
No problem. The And if you're picking the biggest ewe lamb or the biggest ram lamb in the selection pen, typically it's going to be a big single out of a 3 or 4 year old or 5 year old dam. And if you've got a maternal breed, and you're really hurting your flock. You know, one of my mentors, and he grew up in a time when you hand milk your cows. Even though I'm in my 60s, we didn't do that. And you know, selection is a 3-legged stool, you know, milking stool, and if any one of them breaks or isn't there, the stool falls over. But by far the most important, well, you know, we talked a little briefly about conformation. You know, pedigree is important. If you're recording performance on several generations, pedigrees can help. You know, if you stack that pedigree, that helps. But performance is the key one. So let's look at some, since we're looking at data and weights, let's look at some weights here. So we have a nice range of weights on, you know, 50-day adjusted. So we've adjusted for age of the dam, number born, number raised. And we have 15, 20, 25, and 30 kilograms. So, you know, the question I pose is which of the above are really different, you know, really different from each other. If you pick a 30 kilogram lamb and over a 25 kilogram lamb, how are you assured that the 30 is actually going to be growthier than the 25? Well, I mean, if the numbers are really widespread, we know that you can probably call the 15 and 20, and the 30 is probably better than both of those. Definitely better than, but you know, highly probable that it's better than the 15 kilogram. So in this is where performance evaluation starts becoming important, because it really helps us make these decisions. So the important thing to know about this is that at 50 to 60 days, only 10% of the difference. So if we look at that 30 kilogram lamb and the 25 kilogram lamb, and the research has shown that if you take, we'll just for example, say you take 50 sires that are 5 kilograms heavier than at 50 days than 50 others, and you use them, you only get 10% of the difference between those two is genetic. So between the 30 and 25 kilograms, that's half a kilogram or around a pound. And that's all the consistent genetic difference there are between two animals raised together, adjusted for age and number born. There's only a half kilogram difference. And to me, this is what makes it hard for the sheep breeder to select superior animals, is because of this small 90% of the differences between two animals at 50 days and their weight is not genetic. It's noise. You only get a small return for selecting that. And, you know, since the early, you know, for the last 18, 20 years, when I've been writing articles for sheep producers, I put this table in there. And to me, this table says it all, why we need more than just the scale, why we need more than, and especially more than visual selection. So, and if we want to make progress, we need to figure out, well, how do I take that 10%, you know, of the 50, 60-day weights, or the 20% of the 120-day weights, and how do I magnify that? How do I get more accuracy out of this, so that when you select a sire, you actually are getting more growth? Or if you have a 130% lamb crop and you're selecting within the breed, how do I increase that 10% difference? And to me, this is the take-home message of why you need to do performance evaluation, why you need to have data, and why you need to submit to a performance program. Is so little of what we see in the differences is genetic. Now, there's certain traits that are definitely more highly heritable. The older an animal gets, the older they are. So at 240 days, the difference in 40% of the difference in weight is heritable. And also at 240 days, you know, you might have 30 kilograms difference. You know, you can really get some differences in weights at that point. Carcass traits are more heritable. If you take the, you know, if you break the animal down and weigh the cuts, or the hanging carcass, that's more heritable than growth early on. I didn't put any wool up here, but wool's in that 50%. The differences in fiber diameter, differences in greasy fleece weight, total weight, those are in that 45 to 55%. I'm going to do did a quick drawing to help illustrate what we're talking about on this 10% heritability. This is a well-fed polypay. I mean, he definitely saw a fair amount of corn, but he had the right position for me to be able to do things. So the weaning weight's 10% heritable. So I drew this yellow there, and so you really only 10% of what you see at weaning weight, and granted this is a mature ram, but 10% of what you see is the component that's heritable. 90% of what you see is noise. As an animal gets older, I put, you know, the reddish orange, showing that as an animal gets older, more of the animal, the differences in what we weigh is heritable. So that's still not much of an animal. So how do we find out or increase our accuracy at selecting for better growth or better traits? And the answer is to include the performance of half sibs and relatives. So if 80% of the half siblings are heavier than lambs out of another sire, since it's in 80% of them, that means it's genetic. You know, that means that this weight is real. It's not that this lamb had that its mom took better care of it, it got more milk or whatever, and so much of its growth is due to that. But if you have 20 or 30 or 50 other half siblings out there, that really improves our ability. And so it's this, so when they develop BLUP and programs like, you know, and the science behind Genovis, science behind the National Sheep Improvement Program, it was the including of being able to figure out how to statistically include the performance of relatives. And it's directly compared within the lamb crop that is of the same age. And for relatives in other flocks, that's also, and we don't need to go into science. I still treat it as a black box. I'm the quantitative geneticist I've worked with, tell us to do it as well. So, they're able to include the performance of relatives, and it's this performance of relatives that starts increasing our accuracy of selection, starts convincing us with those accuracy measurements that the increased weight, or the fact that the lambs out of this sire are always smaller, whether and you don't want to use that sire. And the way that they're compared between flocks, and this is a common thing that people question, accounts for the differences in management. And it's a ratio method. They aren't carrying, they compare the differences from the mean of a group of lambs. So and it's done in a ratio method. And this ratio method is real powerful. And it does a good enough job at accounting for differences in management that the genetic portion stands out. And so it's a relative comparison between flocks and a direct comparison within a group of lambs that are raised together, or a group of ewes that are lambing for number born and number weaned. So we have well-tested genetic programs and developed on great, developed on this best linear unbiased predictors, BLUP. Canada has Genovis. I've been very active in the National Sheep Improvement Program in the US. In the last 10 years, we've been working with Lamb Plant in Australia for our data. In the dairy and beef cattle industries in US and Canada have used it. Poultry has had incredible success. For some of it's the biology of a chicken, because a hen can have 100 offspring per year. And that does a pretty good job of taking the chance out of performance, and a rooster can have several thousand. So, and they've all used it, and much better than most of the sheep industries around the world. So I was going to go back to that, that same drawing I'd done before. And remember, the yellow was the 10%. If you had the yellow and the reddish orange together, you get the 20% that you see for post weaning. And then when you start adding in the performance of relatives, you get more and more of that animal's difference that, that we can say is heritable. Well, being a Katahdin breeder, to me, the place that's most important for the sheep industry is to look at lamb crop born and weaned, and profit. And profit in pretty much in most of these industries is the reproductive performance. If you can market 2 lambs or per ewe, you're going to make more money than somebody only marketing 1.3. And the sheep industry really needs good reproductive performance in their ewes and rams. And our standard techniques of looking or weighing are not effective. And there are ways to use records and EPDs. I mean, also, just the way, we're looking at 0 weaned, 1 weaned, 2 weaned, 3 weaned. You can't, you might have the potential, if she lambed 100 times, to have 2.3 lambs, over the course of 100 lambings, but we never keep a ewe that long. So we need statistical programs that can help with that. Here's a ewe with twins. I have to show a few pictures. Now, EPDs are going to be the most accurate, but not all of us have access. Not all of our commercial producers have access to EPDs, and here's, I think, one of the better tools or record keeping that can be done to help identify good better reproductive performance. So if a 2-year-old ewe has twins and raises twins, that's 10% heritable. But we look at 3 consecutive years, and so the two, and I don't know how many of you are familiar with dam production record. The first number before the slash is number born. The second is the number weaned. If you put 3 records together, 3 years in a row, 2, 2, 2, 2, 2, 2, those differences are 30% heritable compared to ewes lambing at the same time under the same treatments that would, like the one below, which is 1, 1, 1, 1, 1, 0. And in maternal breeds, or if you're keeping ewes back, especially commercial flocks, they should be keeping daughters out of ewes that have good track records of reproductive success. That's going to help maintain that. Here's another demonstration of the same thing. If you look at dam number 3, she's had 5 lamb crops, 15 lambs, and has only weaned 6 lambs, only 4, which is about 40%. Dam 1 and dam 2, are both very good ewes, and for a commercial flock wanting wanting to wean at least twins. So as I mentioned before, you increase accuracy by incorporating the performance of relatives within flocks and between flocks. And our personal, and it takes, and that's where, the sheep industry and science, where we need to use the sheep industry and scientists that have a background in quantitative genetics to be able to do that. And I went and picked some information off the Genovis website to show some of the trends that flocks and Genovis have been getting, and I just picked a couple. There's about, what are there, 15, 20 breeds with about 10 to 12 of these trend lines per breed. And this is the genetic trend for 50-day weights for the Rideau Arco. You can see there's been a steady increase for the breed using Genovis. I mean, Suffolks are showing the same trend, maybe a little steeper, which is what you know they would put more pressure. You know, and Suffolks are going to do more on muscling and growth, so that's not that would be expected. There's another one for total weight weaned. So for the first lambing of a ewe when they're younger. And again, you see a decent trend. And then here's older ewes. So the flocks that are involved in Genovis, especially those breeds that have active participation, are seeing good success in improving the genetics of their breeds and their flocks. So that, you know, EPDs are calculated using a well-documented math and statistics programs, including the performance of relatives with the performance of individuals, removes the impacts of management, you know, and the, you know, the key reason to do it is to increase accuracy. You know, we do that. We're more certain, takes some more of the guesswork out of picking the best ram or the best ewes, keeping your keepers, making better progress. You know, I mean, there's no other method that compares. And if you want to improve the production in your flock, if you want to have a more efficient system, you need to be using estimated progeny differences to identify the sires you use. And you know, moving toward the end here, just wanted to bring this up as what is possible with the adoption of more modern technologies. We can see that the same cow can produce 30 to 40% more meat per year and have fewer total animals on the place. Now, sheep are, you know, they provide an advantage. We don't have as much artificial insemination as beef cattle do. That's part of the reason they've had good success. But we can make up for that in a couple ways, because our sheep can have multiple births, so we can greatly increase the production of lamb in our countries just by increasing the number born and weaned. Sheep have a shorter generation interval. I know cattle, you know, it's often 3, 4, 5 years before a heifer, you know, has raised a calf to weaning, and especially to post weaning. Whereas with sheep, I mean, we're often marketing, you know, you have a ewe that's a year old and you're marketing lambs within a year. And with EPDs, we're able to compare the performance of yearling ewes with 4 and 5 year old ewes and still get accuracy. So just repeating much of what I've said. Visual evaluation, which has been much of the standard for the last 300 years, is not effective at predicting performance or meat production. It's not effective at identifying reproductive efficiency. And what I always tell people at my talks is we need to start demanding more records and EPDs from RAM suppliers. Encourage them. If you buy a ram whose daughters produce, let's say you go from 1.5 to 1.8 lambs per litter, and you keep 20 of his daughters, that's about 12 to 30, that's 6 to 8 lambs a year, $200 $200 to $300 a lamb. That's $1,000 per year return from buying a ram that has 0.3 more, whose daughters have 0.3 more lambs. And you can also do the same similar calculation with a terminal sire. If you have 50 lambs that weigh 5 kilograms more, that's 250 kilograms. Depending on the time of year, that could be $3 to $5. Again, it's over $1,000 a year that you return from buying a sire that takes you to a new level. One of the other things, that's in the breeds in the US that have had the best success using EPDs, those registered breeders are working together. They're buying the rams they want, but I'm willing to sell or trade a good ram to another flock, because if they make a better ram that's not as related to mine, I can bring offspring back. So it's all working together. You don't use, the best success with EPDs comes from working together with other flocks. And it's not to say I've got better lambs than everybody else. It's about how I can make my flock or genetics better. If you put that, I want to make my flock or genetics better, it's not out there. You're not out there to say, I want I want to show that my sheep are best. You make the best progress that way. Okay.
Oh, thank you very much, Dr. Morgan. That was very, very informative. Do we have any questions for Jim?
Sure. I don't know how to raise my hand or anything, so I just unmuted myself. Okay, what is the effect of using something like PMSG? That's one of my questions. Okay, I don't let a ewe raise more than 2, so I pull them off and bottle feed them. And then what is the effect of breeding out of season? Hello?
Yeah. Yes. So I didn't catch your first question, but the breeding out of season. So they're only being directly compared to ewes that are lambing at the same time in the same flock. So ewes that lamb in the fall are going to have fewer lambs per litter, but it will work out. I was doing some look at the Genovus website, and they do have a EPD for interval between lambing, which would pick up, which I assume the reason they were doing that was to get out of season breeding.
Okay, the first question was like on PMSG. And so then I have, some of my sheep have like, I have Ritos and some of them, even without PMSG, will have 4 lambs, right? So
Right.
I only allow her to raise 2 of them, and I pull 2 off and raise them on a machine.
And so different breeds are going to need to use different sets of EPDs. You know, in the Ritos, I would, you don't really need the number born so much as you do need lamb survival. Now, with the machine, with the machine, you're definitely you can definitely get good growth, and it works really well. Research at the major meat research center in the US, which is in Nebraska, USDA Meat Out Research Center, they have ewes now that will raise triplets on grass with no grain, wean triplets. I think ewes can do more, and you can identify genetics of ewes that will raise triplets. Now, quadruplets is a different story. But yeah, that's a little bit harder if you've got quadruplets. But triplets, and do work. The polypay breeders in the US, many of them are going for triplets, and letting the ewe raise the triplets.
And then what about PMSG? I mean, that makes you have more lambs, right?
That's more to help with,
With
less familiar with that. I think it, and maybe
it increases.
Ileana can step in and answer that one. It mostly increases the likelihood that they're going to breed, is what I remember from my courses.
I thought it increased the ovulation too.
I can probably jump in a little bit there. Yes, PMSG will increase ovulation to a certain extent, depending on the breed and the time of year and all those other things that matter to breeding. I guess I'm wondering why would you be using the PMSG in Ritos would be one question. It would be to tighten their ovulation. We always use PMSG with AI programs, and that just tightens the synchrony in a group. If that's what you're after with it, or are you actually looking to increase ovulation in your use?
I use it when, especially like out of season breeding.
Okay, yeah, fair. So you're using cedars as well then?
Yeah.
Yeah, okay. So you need to be careful how much PMSG you give to Ritos, or you'll get a lot of lambs, but yes, it will increase ovulation rate with all those other factored into.
I found that out with Romanovs too. It not that good a deal.
Yeah.
Yeah.
Yeah, you'll be glad for the milk machine.
All right.
I actually do have a question. I'm wondering, Jim, if you could comment on the use of sire reference programs to increase the rate of genetic gain for these kind of traits.
That's another. It works best if you have AI, and I don't, so if you have AI, and let's say, and it's been used a lot in the United Kingdom, where in one day they can move semen from a ram, across much of the UK, so sire reference, and they put a couple couple of lambs, or they breed a couple of ewes per flock with a certain number of sires in their sire reference programs. So it's worked real well in the UK. I don't think it's that much of an option for the US, where there isn't enough AI, and the sheep flocks are, I mean, there aren't enough, there's, what is there, 20 or 30 million sheep in the UK, and there's 5 million in the US. It's just.
So can you still make reasonable genetic gains if you say use half brothers or,
Yeah.
sons of a particular?
Well, they're still, those sire references in the UK are still being used with EPDs. They're used to increase the accuracy of the EPDs.
Right.
So if you have, so let's say a breed like the Suffolks, they pick, and they usually, as I recall, in the UK, they'll pick like 30 Suffolks this year to use as sires, and then they move semen from those, and then each flock decides which of the 30 they want, and they sort of barter, and then they move those out. And by having a few lambs of every sires, that really helps with removing the management differences between the flocks. That's the value of the sire referencing, is that it helps with removing, some of the management differences that are, that we struggle with them less, in EPD programs, but they still slow progress. But yeah, you can make some progress. But a lot of people like ram tests, where you nominate a couple rams from your flock and every other, and you put, of the same breed, and you put them all in one place and grow them together. But they've had different, they were raised differently, so the differences you see during the test are not as accurate as it would be as a good EPD program.
Right. So you're still the closer the genetic ties between the flocks, the more accurate your EPDs.
Yeah. You make progress trading you trade really good rams, in the US breeds that are making the best progress, EPDs, you're trading your best rams to your competitors. So with the idea that they will trade you a better one back. And by having more flocks involved, so, you could have 50 ewes and this other flock has 75, but you get 10 flocks together with 1,000 ewes. Now you have a flock size of 1,000, and there's always a few really good outliers, really good rams out of 1,000 ewes. Right. So by cooperating, you really increase the number of ewes, you increase the effective size of your flock up to 1,000 or 2,000 ewes, which will, you get that rare ram that gets the best genes from both his parents in multiple, in growth and muscling, if you're interested in wool, and also in maternal.
And then we might have to have a complete another presentation on biosecurity of swapping rams around between flocks.
Can I ask a question?
I'm careful about who I get them from, and then I'm also far enough south that ovine progressive pneumonia isn't as effective at spreading.
Yeah, go ahead with your question, Lynette.
Yeah, I just wanted to question why we don't use something like flushing a little more often. And if flushing can definitely increase your lambing percentage, this isn't really strictly genetic then, is it? So one year my ewes got out into the alfalfa field that I didn't know about, and I had a quarter of my flock had quads, which was not great because I had a lot of lambs to feed, right? But I mean, back where I started off with sheep, flushing was something that was used extensively. Do we not consider it here that much, or do you think it has anything to do in management that we should be using more often? Jim?
So, if I had the Ritos, no. Unless your machine works real well. So I think, flushing and the use of teasers is important, especially when you're breeding during longer days. My flock used to do 250, 260% breeding in, first of November. I don't need to flush, but those Katahdin flocks that bred in August did. And then the use of teasers as well. Or PMSG and PMSGs and cedars seem to do more with synchronizing and do help with ovulation some. But yeah, no, flushing can be used. I think it just depends on the breed and the time of the year. And again, Ileana probably, reproductive hasn't been what I've studied. So but the commercial flocks, the ewes in the commercial flocks need flushing helps. You can select on survival. You can select on, I lamb on pasture, so I get a pretty good idea who is raising their lambs and who doesn't. There's when I advertise my flock, I say I'm breeding for parasite resistance in ewes who never lose lambs. And out on pasture, that's a good goal.
Were there any further questions? Bernadette, did you have a question about parasites?
I didn't talk about parasites, thinking that Canada didn't have that many. But we can take about 2 minutes here. So I have lambs in my flock at 60 days and 120 days will have 0 eggs per gram, and some that have 10,000 eggs. That's one trait. That's one trait where you almost don't need EPDs, because we know that you can make a lot of progress just because there's 4 orders of magnitude. With weight, you have a lamb that's 5 or 10 kilograms heavier. It's not even twice as large. But with parasites, there can be really large fecal egg count numbers, and you can make good progress with it. Now, the types of worms probably more prevalent, species of worms more prevalent in Canada won't have the high fecal egg counts that we see here in the southeastern U.S. The barber pole worm just is a lot more fecund, has a lot more eggs. If anybody wanted to know more on that, I could talk again sometime.
Oh, there were no other questions in the chat, Lena.
Okay. Okay, do we have anybody else with any further questions then for Dr. Morgan? Right, nobody's jumping in, so I guess with that, I would like to really thank you, Jim, for talking to us tonight and all the participants who joined us. This will conclude the webinar, and we'll be sending an email to everyone who registered with information about how to access the recordings, and everyone should have been sent the PowerPoints already if they were registered, but we will have a place where you can access the recordings. So thank you very much, Dr. Morgan. We really appreciate your time. And this is just a quick reminder for everybody that the Alberta Sheep Breeders Association Annual General Meeting will be held November 27th via Zoom call from 2 to 3 p.m. That's a Saturday. And please check the ASBA website for details about how to join the AGM. All right. Thank you very much, everybody, and have a good night.